In this last video in this section, we will look at monitoring concepts in Kubernetes. Monitoring is concerned with solving two different kinds of problems. The first problem is providing metrics for Kubernetes' own use. The second problem is presenting the metrics to users of the cluster. The solution to the first problem is referred to as the core metrics pipeline, and the solution to the second problem is known as a monitoring pipeline. To understand the pipelines, we first need to understand the different kind of metrics that are available in the cluster. This diagram explains the kinds of metrics. At the top level, the metrics are divided into system metrics and service metrics. System metrics are again divided into core metrics and non-core metrics. The core metrics refer to metrics from a monitored entity. This consists of node level and pod level disk usage, CPU, and memory. The non-core metrics could be additional metrics that are not used by Kubernetes itself, but can be exposed to external tools and hence a part of the monitoring pipeline. Service metrics are metrics from Kubernetes applications and from user-deployed applications. The service metrics and the non-core system metrics form part of the monitoring pipeline, and we will look at a demo of that later on when we install Prometheus. For now, let's look at the components of the core pipeline. This slide describes the core pipeline, and at the very basic level we have the kubelet. The kubelet contains a tool called cAdvisor. cAdvisor is a tool that provides container resource usage and performance metrics. It is not part of Kubernetes and does not have any knowledge about Kubernetes. The kubelet uses the metrics from cAdvisor and combines it with its own knowledge of Kubernetes pods and other entities to create summary statistics. These summary statistics are exposed outside the node via Summary API. Some of these metrics are used by the metrics server and form part of the core pipeline. The metrics server collects statistics from all nodes and stores the latest value in memory. Kubernetes components can then obtain the metrics via the API server using the metrics API. The Kubernetes components that use these metrics are the scheduler, kubectl top, Kubernetes dashboard, vertical and horizontal pod autoscaler, and cluster federation. The monitoring pipeline handles custom metrics in addition to those provided by the core pipeline. Kubernetes does not provide a tool for monitoring, but we can install an external tool to handle the custom metrics. In this video, we will be looking at how to use Prometheus for the monitoring pipeline. There are multiple ways to install Prometheus, but probably the best way to install Prometheus in Kubernetes is to use the Prometheus operator. Operators have been developed by CoreOS and they are a way to manage Kubernetes applications. They allow additional functionality compared to a simple package manager such as Helm. For example, if you need to install a database and configure it as well, a database operator would help you do that. An operator adds lifecycle management to an application and can be installed using Helm. There is a Helm chart for Prometheus operator. However, we'll install the operator from scratch just so that it gives us more control on what we are installing. We begin by creating the cluster in AWS using KOps. To create the cluster, set the name and KOps state store variables and then create the cluster definition. Once the cluster definition is created, we need to edit its definition by typing in KOps edit cluster name. This will open up an editor. Add authentication token webhook :true and authentication mode :webhook in the kubelet parameters. Once that is done, create the cluster in AWS by typing in KOps update cluster cluster name --yes. While the cluster is starting, we will install the tools required to configure the Prometheus operator. The operator needs Go, so we install Go 1.10 using the following steps on Ubuntu. The first three steps install Go, and the last step puts it in the executable path. Once Go is installed, we need to install three libraries: JB, GoJSON to YAML, and JSONNet. The library binaries are created in a directory called Go inside the home folder. We need to put those binaries in path. Once the libraries are installed, we create a folder called mykubeprometheus. Inside that folder, we run jb init. Once that is done, run jb installed followed by path of Kubernetes operator to install the operator and its dependencies. That might take a while. Once that is done, create a file called prom.jsonnet. Copy the contents from the file in the Kubernetes monitoring folder of the course. This file can be edited to configure the components that we want to install. Similarly, create a file called build.sh and fill it with the contents from Kubernetes monitoring folder. To create the YAML files for Prometheus and Grafana, type in /build.sh prom.jsonnet. This will create a folder called manifest. Type in kubectl apply -f manifest. This will create Prometheus and Grafana resources. Let's look at the list of services, and we see services for Prometheus and Grafana. We will expose the Prometheus and Grafana service as type node port so that you can access it from our machine. In a production setup, we'll probably change the ingress rules to allow access to it. Let's keep a note of the port numbers and the IP of the nodes. We need to add the node ports to the nodes security group. Let me open up the AWS console. Click on security groups and then edit the inbound rules for the node security group. We first access Prometheus using IP of any node and the node port. Let's look at a metric to make sure the data is reaching Prometheus. The data seems to be coming in. Next, let's look at the Grafana dashboard. The default username and password is admin, which we are prompted to change after login. We will not go through the Grafana dashboard in this course, but let's make sure the metrics are reaching here. Click on Dashboard and then Manage, and you should be able to see some dashboards. If we click on Nodes, we can see some graphs for the nodes. The data seems to be coming in fine, which means our setup is working fine. Grafana dashboards can be very powerful, and in a production system, we would probably also have an alerting system. There is an easier way to install Grafana and Prometheus if you don't want to configure it too much. There is a hem chart for the Prometheus operator. To install using the hem chart instead, type in hem install --name Prometheus stable /Prometheus operator. Tiller needs to be installed with a service account that has all the required permissions. To create the service account with the required permissions, use the tiller_role.yaml file inside the Kubernetes_monitoring directory in the Kubernetes course project. Once the accounts are created, init hem with hem init --service--account equals tiller. This finishes our video on monitoring in Kubernetes. There are multiple ways to install Grafana and Prometheus, and you can choose one depending on how configurable you want the deployment to be. That's all for now. See you in the next video.